go. So what we're looking at is we're looking at problem-solving strategies. Okay, and I'm going to try to keep this up as long as I can. But what you're seeing here is that the first thing that we got to do here is that we got to derive the first order equation. Pay attention here. Okay, this stuff gets tricky. I'm going to pick the easiest possible circuit. That's it. It can't get easier than this. Okay? What you're going to find here is that if I have a capacitor circuit, I got to connect VC and IC. I don't care how you do it. Maybe it's a KCL, maybe it's a KVL, maybe it's both. If it's an inductor circuit, it's IL and VL. And you're going to write that and get your first order equation. Once we get our first order equation, then, as we discussed before, we have to have the form for the particular solution or the force solution as that effective source. That's what it has to be. So how about if I not go there and let's just do step 1 and step 2. So what I'm going to do here is that I'm going to use KVL to connect VC and IC. From that, I'm going to get my equation. From this equation, I'm going to make an assumption about what the source solution has to be here. It's going to look, you're going to see here that we're going to get a linear combination of a sine and cosine, and then we have our natural response. So we want to get this, and then we want to write down what the solution is. So here we go. So the way I kind of look at this thing here is that I try to get into what I say a rhythm. Don't try to memorize steps. Try to get into a rhythm of saying, like, okay, I do this, then I do that. And then I just keep kind of moving here. So what I'm doing here is that I'm setting up 2 steps in one whoosh, if I could say that. I'm going to write this down. Once I write this down, I want that solution. From the solution, I want B1 and B2. Here we go. So what do I have? Here's an example of the first order calculation. You can see here that this is a sine function. So I have an amplitude of 10 volts, an angular frequency of 20. It turns on when? At t equal to 0. Right? This function less than 0 is 0. So I got my resistor, my capacitor. This is what I'm interested in. I have an initial condition. So that means at the moment I plug this guy in, then this guy starts simultaneously, or either way you can think about it. So here I go. So what do I want to do? Besides spill ink all over the place, I want to apply KVL. Okay, I want to apply KVL. Here we go. So right here, then, what I'm going to do here is that I'm going to apply KVL to connect IC and VC. So as I do this, then we can see if I go around the circuit here, we can see here that I got to have what? I got to have the voltage across the 10 ohm plus the voltage across the cap, which is the voltage across the source, and this guy has to be 10 sine of 20t. So what do? I got to convert that 10 ohm resistor into a current. So then I'm going to say that this is 10 IC plus VC, and then I got to rewrite IC in terms of what? Where IC has to be C dV dt. So then I'm going to plug that guy in here. So I'm going to get 10. What's the capacitance here? You see that it's 10 milli here. This is not 16. So then I'm going to get 10 times 10 to the negative 3. Okay, that's what the capacitance is. And then I'm going to get dV dt plus Vc equals to 10 sine 20t. So when I look at this guy here, what I'm seeing here is that I get 10 to the 2 times 10 to the negative 3 gives me 1 over 10. So what am I going to do? I'm going to multiply everything by 10. So if I multiply everything by 10, that means I need to isolate this guy. So then I'm going to get dv dt plus 10 Vc equals 100 sine of 20t. And that's my first order equation. Okay? So that right there is step 1. So then the next thing, what I'm going to do here, is that I'm going to get my general response, if I could say. So now I'm at step 2. And if you look at step 2 here, I've got to derive this general response equation. Okay? So my general response equation tells me this here. So when I derive general response equation, what do I mean by general response? That means I haven't solved for the constants, which I'm going to call A and B1 and B2. So this means that there's a, so that means that A, B1, and B2 are unknown. When I have those solutions for A, B1, and B2, then I have the full solution. So what I'm going to do here is that I'm going to focus on the force response. So if I focus on the force response, this implies here that my voltage, Vc here, has to be proportional to this guy right here. But as you remember from differential equations here, if you have a sine function or a cosine function, you have to write that as a linear combination of the two. And what that effectively does here is it just spans the solution space, just sort of like vectors. So this implies here that the forcing response, which I'll just call Vf, should then be a linear combination of this guy. So I'm going to call this, just to make sure I get my B's right, I called it this way. So it's going to be V1 sine 20t plus V2 cosine of 20t. That's what I assume the solution is. So if I look at the natural response, I typically symbolize that with the constant A. So if I look at the natural response, what we're seeing here is that you get the following thing here. It's got to be a constant A, and from constant sources here, we know that the natural response is a constant A, and then we get e to the minus t over tau. But we know what tau is. Why do we know that tau? Because of that cofactor right there. And you can see in this equation right here that it's x divided by tau, or more importantly, 1 over tau. So that means that 10 must be 1 over tau. So this tells us here, so from our equation here, we see that 1 over tau is equal to 10. So therefore, I write this as a e to the minus 10t. So then if I come over here, I could then say that my general response equation is b cap of t, so it's got to be a e to the minus 10t plus b1 sine of 20t plus b2 cosine of 20t. And so right here, this is my general response. So just by inspection, of this equation, you should immediately write that down. So I'm thinking of step 1 and step 2 is this process that you just go like, okay, here's the equation, here's the general response. So in order to solve for the constant A, we actually need B1 and B2 first. So what we say here is that the constant A is defined by the initial condition, which tells us that's at VC of 0 minus, it's actually 4 volts. But in order to do that, I have to determine V1 and V2. So the way we determine V1 and V2 here, you could do this one of two ways. I take this equation, I plug it right into here, and one of the things that you're going to find here is that that constant A immediately cancels out. It just drops out of the picture. However, a shortcut is to take the force response and plug it back into this equation right here. When you do that, you're going to set up conditions on V1 and V2, which we could solve. So what we want to do then is that we want to substitute V force or V forcing into first order equation to determine V1 and V2. Okay, that's what we want to do. So here we go. So our equation then says that df dt plus 10 vf equals what? Well, I'm going to take my force response and I'm going to plug it back in here. So look, there's the force response right there. Right? That's the force response. So if I take a derivative of this term, I'm going to get what? So I'm going to get cosine, right? And then I'm going to get a 20 factor out here. So I got to take the derivative of the first term. Maybe I should just write it out to make sure that was good. So it's got to be B1 sine of 20t, B2 cosine of 20t, plus 10 B1 sine of 20t, plus B2 cosine of 20t. And that all has to equal the term 100 sine of 20t. So if I take the derivative of this guy, right, here we go. So I'm going to get what? I'm going to get, so if I differentiate this guy, I get a positive sign. So I'm going to get minus 20 B1 cosine of 20t. I take the derivative of this guy, I'm going to get a negative sign. So I don't know why I have a negative sign there. But then I'm going to get negative 20 B2 sine of 20t. Then I'm going to factor out these guys right here. So if I do that, note that I'm going to take my sine factor and I'm going to write it right underneath here. So then I'm going to get plus B1, 10B1 sine of 20t. And then this guy I'm going to put right here by the cosine. I'm going to get plus 10B2 cosine of 20t. And this whole thing here has to equal 100 sine of 20t. So what you're seeing here is that the way I wrote it here, the only reason why I didn't write it the other way, long ways here, because I just wanted to focus on what? Cosine of 20. And if I look at sine of 20, so I have like terms. So if I group these guys together, right, so now we're going to be grouping like terms. think I'm going to move it that way. Okay. So if I'm grouping like terms here, what you're going to see here, then I'm going to get what? I'm going to get, let's see, what do I have positives? So I got two positives here with the cosine, and I got a negative with the sine. So let me make sure I don't screw this up. So I'm going to get 20b1 plus 10b2 cosine of 20t. Right? That looks good to me. And then I'm going to factor out that sine here, and I'm going to get plus 10b1 minus 20b2 sine of 20t. Right, I think that's good. Okay, and that has to equal 100 sine of 20t. So if you look at this term right here, if these guys are orthogonal, the only way these guys can be true is if this side equals that side. So if that's true here, then that means since there is no cosine term over here, it means that this guy right here must equal 0 because there's no cosine on the other term, on the other side. So immediately I can write an equation that says 10b1 plus 10b2 has to equal 0. Otherwise it doesn't make any sense. That's the only way you can have that. Now if I look over here, you can see that the sine 20 term has to, the cofactors have to equal. So this here, what we say then, must equal 100. So if I write this equation here, I can write this as what? 10b1 minus 20b2 has to equal 100. So just to get my coefficients b1 and b2, I got a 2 by 2 matrix. Right? There's a lot of ways to solve this thing. I'm going to let you figure it out. Right? This is a very nice equation. Right? Compared to what we've been seeing here. And so what I get here is that I get b1 is equal to 2, b2 is equal to minus 4. Okay? So now I have my constants b1 and b2. So I'm going to take those constants and I'm going to plug it right into this guy right here, into the complete response. So now we sub back into the general response equation. So if I do that, I now have Vc of t. I have a e to the minus 10 tau plus 2 sine of 20t minus 4 cosine of 20t. Okay? So that's where we're at. We got that guy just by intuition, with practice of differential equations already, and all we did here is assume that the forced response had to be this part, and the natural response is still the natural response. So we got this. So now where we're at. So if I come all the way up, down here, and this process here, we're at step 3. So step 3 here says that I have to do what? I have to solve for the initial condition for the capacitor, and then I apply my initial condition to this equation right here to get the constant A. Okay? I need this B1 and B2 to be in place here. Now note, it's just not going to be that easy. You know what you're going to have to do? You're probably going to have to do a chapter 7 circuit just to get this initial condition. We're doing this here to get you to see the overall process. So here we go. So now we're at step 3. So what we want to do here is that we want to solve for the initial condition, VC of 0 minus, which in this case is 4B. So we're sitting sweet right there, right? Because we don't have to solve for it. It's given. And apply this to determine constant A. So let's do that. So I'm going to take this guy, and I'm going to say that VC of 0 has to be VC of 0 plus, and this guy is 4 volts. So if I look at this equation now, I'm going to substitute in 0 for here. So if I substitute for 0, what you're going to see here is that I'm going to get A, right? E to the 0, which is 1. Sine of 0 is 0. Cosine of 0 is 1. So then I'm going to get a term that's 0, and then I'm going to get minus 4. So if you look at this constant here, this immediately implies here that A has to be 8. And with our units, it has to be 8 volts. So what's the total response to this circuit here? Well, the complete response so then the complete response is VC of t. Now if I plug that in, it's going to give me 8 e to the minus 10t plus 2 sine of 20t minus 4 cosine of 20t. So now we have our solution. So what I did here is that I went into PSpice, and then I looked at some of these, I went in PSpice and I wired the circuit or captured the circuit. And what I want to do here is that I don't really want to go over this in class. And the reason why is because we've got 2 more circuits to do, right? We want to practice the hell out of you to make sure that when you come on Wednesday, you're ready to do this, because one of these babies is out there. I'll tell you that right now. Okay? So if you go to my solution, my notes in class lecture here, which is going to be really hard to see. Okay, I should have actually did this, and I'll have to go back and change the color on this guy. Isn't it obvious? Well, what I ended up doing here, you'll see that there's a sinusoidal which you can't see. Then I went in and I started to look at the solution. Well, is this guy the same as 4 volts after? Right? You need continuity. And if I had a better image of my screenshot there, you would have seen that it would have been continuous. So if I calculate this thing, I get 4 volts. And then another thing here is the frequency of the circuit still, 20, rads per second. So you could go in and you could measure peak to peak, and I still get this rad as the solution. That would have said here. And then I went in and I calculated what's the maximum voltage that at the steady state, once it reaches steady state. And you'll see that when you do this, you get the steady state solution that looks exactly like this. And how do I know that? Because you could go in and I picked several points here, but what I did here is that I picked one arbitrary point, and then I plugged that in, and when you compare that value up there to this value, you see that they're identical. So I'm calculating the values that PSpice is giving. Okay, so that's essentially where we're at here.